Okay, so the subject of this video is almost teetering on an intermediate side of JavaScript because it's going to get really sort of like gritty into the deep end of JavaScript here. So it's all about equality in this video. So let's just start off by making a number equal to 7, and also let's make a number object. 1, and this object is going to be equal to num7, just like that. No semicolon needed. Also notice when you're done making an object, you don't really need the semicolon there. That's one time in JavaScript where the semicolon isn't needed. 2. Okay, let's just click run, make sure there's no errors. Everything's working. Okay, so the first thing I want to cover is loose equals. Now we've seen that before, when you say number is equal to 7. So it's true. Number is equal to 7. So what this loose equals is because there's only 2 equal signs. Only 2 equal signs means that the equality check will allow implicit coercion. And what does that mean? Well, it just means that it will change the type of one of the values on either side if it has to make the values equal. So what exactly does that mean? Well, you could say number is equal to 7. Now, both of these values aren't the same. Number is a number. There's no quotes there. Here you could put letters here if you want. You could put 7a, and that's value. That's valid. But this is just a 7 in quotes. But because we're loosely checking if it's equal, it will allow coercion. It will allow the 7 in string, the string, to get turned into a number while checking equality. So if we check if this is true, it is. So if you want to check if this is known as strictly equals. It's strictly checking if they're the same value. And at this point, it's going to be false, because one of them is a string and the other one's a number. Also, I believe if you check if true is equal to 1, that's true too. Also, false is equal to 0. So false and 0 aren't the same thing. They're both falsy, but they're not strictly the same value. One of them is a number and one of them is not. So if you check if they're strictly equal, it will say false. They're not exactly the same thing. Now this is where it might get a bit confusing. It's the object equals. So object equals, now you saw earlier when I was creating these variables here, I just copy and pasted this second object. It's the same thing as the first one. Like if I asked you if these objects are equal to each other, you would probably easily be able to say, yes, they are. They're the same thing. They're literally copied and pasted from each other. There's the same amount of spaces. It's just the same thing. But let's see what JavaScript has to say. Is object 1? Let's first try a loose equals. Is object 1 and is number object 1 and number object 2 loosely equal each other? They don't. What about strictly? Do they strictly equal each other? They don't. So this is one of the weird things about objects. When you're checking if an object is equal to another object, you're not checking the value of you're not checking the content of the object. What you're checking is if it's the same value stored in memory. Now that's where I think it might get a bit confusing, and it's a little bit advanced. It's because when you're programming, you don't think about objects in memory. You don't think about that. It's just you have variables and that's basically it. You don't care about where those variables are in memory or how JavaScript is doing what it's doing. All you care about is if it's doing it. But when you're checking if an object is equal, that's where it kind of does matter if you understand what the object in memory is. So how do you make an object equal to another object? Well, you would say, let's make a third number object, 3, and make it equal to number object 1. Now, number object 1 and 3 are going to be equal to each other. True. Number 1 and 3 are equal to each other. But so that's how you get them to be equal, but there might still be something that you might not realize will happen. And before I show you the consequences of this, I want to show you an example of it not happening. So let's say let name is equal to Jesse, and let new name is equal to Jesse 2. Actually, no, that's not what I want to do. I do want to do this, but not immediately. I want to make new name equal to Jesse. Whatever the value is inside of Jesse will be set to this. So this name is going to get reduced to a single value. It's going to get reduced to this, Jesse, and then new name is going to be set to that. And let's show you here. Whoops, cap lock. Okay, let's see this. So they're both going to be the same. Now let's do this. So now let's make new name equal to Jesse 2. Now, new name is equal to Jesse 2, and name is still equal to what it was originally equal to. And that's the difference between normal variables and objects. I was setting new name to be equal to name, but it wasn't being equal to the same object, to the same value in memory. There's two different values in memory right now. If there wasn't, you wouldn't see two different values logged right here. There has to be two different values in memory if there's two different values that pop up in the console. So here when you say new name is equal to name, you're just like getting the value of that and then still making a new a completely new variable in memory that can change without changing the thing that it's based off of. That might be a little bit confusing, but I'm going to show you with objects here. So number object 3 not only is the same as object 1, it is object 1. There's only one value in memory. Let's get rid of object 2. These two objects, there's two different variables, but it's the same thing. If you change one, you change the other too. They're sort of linked together. So that's the reason I just made the other example I just showed you with the name and new name. Those were two different variables. They could be changed separately. Since you're making number object 3 equal to object number 1, it is object number 1. It's just another reference to it. So if you change one, it changes the other. I'll show you. Number object 1 dot number and object number 3 dot number. Let's see this. So they're both going to be 7. 7. And then if you say number object 1 dot number is equal to 10, then right here, number object 1, you expect it to be 10. But you might not expect the number object 3 to also be 10. because again, there's only one value in memory. It's just two references to it. So now they're both 10. And likewise, if you changed 3 to 10, it also changes 1 to 10. So they're still both 10. So you can't change one value without changing the other. Also, if you say number object 3 dot new number is equal to 43, when you console.log number object 1, you will see it has the new number. Even though you're adding the new number, the new num, to object 3, number object 1, let's get rid of this so we could just see that log. So this log, number object 1, has the new number. So whatever you do to one automatically changes the other. And with that, that's all I want to show you in this video. I hope you understand it.